we are going to be talking about a couple properties of exponents. Once again, these are just review of what we've done in Algebra 2, but I feel like it's important for everybody to go ahead and know these. So, quick review over these. The first one we're going to do is the zero exponent. In other words, what happens when we raise something to the zero power. So, let me go ahead and zoom in for y'all a little bit. Okay, awesome. So, this one is very simple, very clear. It states that anything to the zero power, so in other words, if I was taking 25 to the zero power, my answer is just going to be 1. This will always, always, always be the case, but make sure that you know what it is that you're raising to the zero power. For example, if I was going to raise negative 25 to the zero power, this is going to give me negative 1. Because that negative, I'm not raising that to the zero power. I'm just raising the 25 and the negative just goes along to my answer. In other words, is there a difference between 2xy to the zero power and 2xy to the zero power? What's the difference between these two?
The parentheses?
The parentheses, yeah. So what does that do? How does that change my answer?
Well, the y in the first one is the only one affected by the zero.
Exactly. So the y in the first one is going to be the only one affected by the zero. So it's going to be 2x times, what is y to the zero power? That's just 1, right? That's the rule we're talking about. So my answer to this is going to be 2x. And what about this one down here? What's being affected by to the zero power? The whole thing. So in this case, this whole thing is just going to be 1. Now this next one's semi-new. So this next one is one that I really want to touch on because we're going to be using this one a lot in the coming weeks. And this is that when we have something raised to a negative power, we take the positive reciprocal of that. It's a very complicated explanation just to say that whenever we take 4 to the negative 3, all we do is, because of this negative right here, we're going to take the reciprocal of 4, which is going to be 1/4, and we're going to raise this to the to the positive 3 power. I messed up on that. 1/4 to the 3rd power. And we can actually solve for this. This is 1/4 times 4 times 4, which is going to give us 1/64. Now, if we were to go backwards, like 1/x to the negative 5, what do y'all think we're going to do? What would be my answer here? Yeah, it'd be x to the power of positive 5. Right? This negative makes us take the reciprocal of 1/x. So the reciprocal of 1/x is just going to be simply x, and then we take the positive power of 5. Are there any questions on these so far? All right, awesome. So this next one right here, ladies and gentlemen, is the multiple powers of the same base. I think they meant to say when you multiply powers with the same base. In other words, let's say we have x to the 5th, and we're multiplying this by x to the 6th. We're multiplying powers with the same base. We're going to go ahead and do what to the exponents? We're going to add them. Now, it's very important for you guys to denote what the terminology is. This right here, the number or the variable that we are raising to a power is going to be called the base. So this x right here is called the base, and this x right here is called the base. So same bases multiplied together, we're going to go ahead and add the exponent. So this is going to be x to the 6 plus 5 which is equal to x to the 11th power. And just like we have terminology for bases, we also have terminology for the number that comes before it. So if we have 4x times 3x to the 4th, x is going to be our base, right? These are bases. And this number that comes right before the x is what we are going to call our initial value. So we have an initial value of 4 and an initial value of 3 and bases of x. So in this case, we're going to multiply our initial values. So 4 times 3 gets multiplied. That gives us 12. We are going to leave our bases the same, and then we're going to add the exponents. What is the exponent of 4x? 1. So we do 1 plus 4, which gives us 5. So we've talked about what happens when we go ahead and multiply two bases with the same amount of exponents, but what would happen if we were trying to divide? What do y'all think we would do? Yeah, we would subtract the exponent. So if we were to do x to the 12th power divided by x to the 4th power, then what we would do is we would go ahead and say, well, this is just going to be x to the 12th minus 4, which is simply going to give us x to the 8th power. Yes. Now, if we have initial values, like 8 and 2, what would this give us? This one, we're actually going to use a couple of rules that we've already worked with. Go ahead and try this out on your own. I'm going to give you all about a couple minutes to do it. I forgot there were magnets in here. Oh well.
What if when you divide this, it's not even distributed?
What do you mean, Madison?
Like let's say it's 8 and 3, 8 divided by 3.
Then you can leave it as a fraction. It depends on the problem whether they're going to want to leave it as a fraction or a decimal. So you're just going to have to watch out for that. But that can definitely happen, and you don't need to freak out about it. You can leave it as a fraction or maybe write it as a decimal. In this case, these do divide evenly, right? So it's going to be 8 divided by 2 and x. Well, this is just going to be 1 minus 4, right? Which turns out to be 4 times x to the negative 3. Can we simplify that? What happens when we take a negative power? We take the positive reciprocal. So what would your answer here be?
Would it be 4 over x cubed?
So let me ask you guys something. What are we raising to the negative 3? Are we raising 4x or just x? Just x. So I'm going to write a little side note here just so that you guys know what's going on. What happens here is you have 4 times x to the negative 3. Now x to the negative 3 becomes 4 times 1 over x to the 3rd power. And what is 4 times 1 over x to the 3rd power? 4 divided by x to the 3rd power. So I want to make sure that everybody's very clear on that this is not going to equal, it is not going to equal 1 over 4x to the 3rd power. This is going to give you 4 over x to the 3rd power. Because remember, you have to remember that 4 is your initial value and x is your base. X is what you're raising to the negative 3 power. Okay, this one's also very simple. And this is also something that you might have seen before. What happens when you raise a power to a power? You multiply them. So this becomes x to the 5th power times 6, which gives you x to the 30th power. And that was just a very simple rule. Now to find a power of two products, for example, let's say we have 3x, and we're raising this whole thing, sorry, we're going to have 3x to the 6th power, and we're raising this whole thing to the 3rd power. Now in this case, since you are raising everything to the 3rd power, you can separate these two and raise each one of them individually to the 3rd power, or basically you're distributing this power. So this becomes 3 to the 3rd power times x to the 6th power raised to the 3rd power. In other words, this is 3 to the 3rd times x to the 6th times 3. And we can just say, what's 3 to the 3rd? 3 times 3 times 3 gives you 27. Times x, 6 times 3 gives you 18. So this is 27x to the 18th power. And lastly, if we have a quotient that we're raising to a power, for example, let's say we have x to the 3rd divided by divided by y to the 4th, and we're raising this whole thing to the 2nd power. Then we once again go ahead and distribute these powers. So this is going to be x to the 2nd times 3 over y to the 4th times 2. Right, we're just multiplying by 2. And this will end up giving us 2 times 3 is 6, so this is x to the 6th divided by x to the 4 times 2. My bad, this is y to the 8th. Now, I do want to ask, ladies and gentlemen, why don't we subtract these two?
Because they're not the same base.
Because they're not the same base, exactly. So remember, whenever you subtract, you have to make sure that they have the same base. No matter what happens, they have to have the same base. I do want to go over one more practice problem. I want to see if you guys can figure this out. Let's say we have 2x to the -2x over y to the 3rd, all raised to the -3. Go ahead and take a few minutes and tell me if you can figure this one out. Now your first step, ladies and gentlemen, what does this negative do to my equation? Anybody? You're going to take the reciprocal. In other words, this is going to equal the reciprocal of 2x over y to the 3rd raised to the 3rd power. So this is going to give you y to the 3rd over 2x raised to the +3. And what do you do with this 3 now? Go ahead and distribute it. This is y to the 3 times 3 over 2x to the 3rd. What happens now? Yeah, so this is going to be y to the 9th. 3 times 3 is 9. Over, you go ahead and distribute this 3 as well. So we have 2 to the 3rd times x to the 3rd, which is just going to give us y to the 9th over 2 to the 3rd is 8 to the x. Sorry, 8x to the 3rd. Are there any questions on this so far? Alrighty then, there we go.